Hey guys, it's Mr. S, and today I would like to talk about circles. Alright, now, circles around you. You've probably seen circles around you. It's pretty much everywhere. From coins, to your eyes, and to water bottles. I mean, it's pretty much anywhere. And today I would like to give some kind of definition, explanation of a circle. I'm going to give you equation, and we're going to look at area, circumference, and pi. Right, so here is a circle. I have three circles right here, and it has no sides. This is not called a side. It's a curve, so you can't call this as a side. So it's not a polygon like triangle, it's not a quadrilateral, it's not a pentagon, it's not those polygons. Now, words that are related to circles could be radius, diameter, and center. You probably want to know those. Center is the center of a circle. It's the middle point of the circle, somewhere around here. You can see my cursor. And radius is from this center to any point on a circle. Maybe from this center to this point, center to this point, wherever. Now, diameter is extending all the way. Passes through the center, connecting the 2 points on a circle. Now, the next thing is I want to talk about similarity. Similar figures. Two figures are similar if they're different shape. Different size, but same shape. Same shape, different size. Same shape, different size. These three circles are circles, right? So they are same shape. But they're in different size. The radius won't be the same, as you can see, just by looking at it. So these three circles are similar. If I add another circle somewhere around here, and I will say this circle is similar to other three circles. It is true that all circles are similar. It's pretty interesting. You can't say all triangles are similar, but you can say circles are similar. Now let's look at equations. The simple way you can write it is x squared plus y squared equal r squared. Now r means radius. Just look at decimals, and here it is. I'm just going to show a couple of examples of circles in a xy coordinate plane. Now, it's x squared plus y squared equal r squared. So instead of putting r, I'm going to put a number that's representing radius. Let's say 4. As you see, it's not in 4. The radius is r squared, so actually 4 is, you can write this as 2 squared, right? Or you can say 4. 2 squared is 4, so either way, you're going to have a circle with the center at 0, radius of 2. You can make it whatever number you want. Now, if you want to have the circle away from the origin, you can do that by adding or subtracting like this. Let me change the number so it's going to be more obvious. If I put x plus 3 instead of x, the circle just moved the center to here, which is negative 3. If it was negative, it goes to the right. Now if you want to move up and down, it's going to be y. You're going to change the y value. Y minus 3, you'll move up. Y plus 3, it's going to move down. Anyway, so here is the just general form of circle equation, x squared plus y squared equal r squared. Right? So one value that is associated with circle is this, pi, the 16th Greek alphabet. Now in math, it represents the ratio of a circle's diameter to its circumference, and it's 3.141592 and so on. It does not end. Now this ratio of a circle's diameter to its circumference. This sentence can be written like this, pi equals c over d. C is the circumference, d is the diameter. From this equation, pi equals c over d, you can look at just the circumference and solve for c to get this, c equal pi times d. This is probably something you've seen in math classes, maybe. Also, you can write this circumference, instead of using d, you can write it using r, the radius, by 2 times pi times r. 2r, twice the radius, will be the diameter. So you've probably seen these equations before, but it's actually from the definition of a pi, the ratio of a circle's diameter to its circumference. Now, before going into area, a few videos earlier, like probably 2 or so, I did the area of a quadrilateral and triangles, and some other figures maybe. In that video I said it's how many space inside a figure, 1 by 1 square. Now, in a circle, its sides, well not sides, but the surroundings are circular, so it's going to be hard to put this rectangular or square and say exactly tell how much the area is. You can estimate those, but you cannot give the exact value. To do so, you have to use this, a equal pi r squared. Now there are a couple of explanations about how the area formula, this a equal pi r squared, was formed. One of them is cutting into sectors, the another is looking at triangles, and then looking at quadrilaterals, pentagons, hexagons, and all the way up to like 100-sided polygon, like 200-sided polygon, all the way, and then it looks like a circle. I'm not going to talk deep about each of those, but I'm just going to show easy ones briefly. Cutting into sectors, cut this circle into sectors. Now I'm cutting into 8, but I think the website that I've seen cut it into maybe 10 or 12 or something. But anyway, once you cut the circle into sectors, you're going to form in this form, pattern. Triangle kind of, and then, well, sector upside down, then sector upside down. And the one part right here, cutting half after you cut the sector into half and place it on each side. This thing looks like a rectangle. Then find the area. Oh, how much is here? How much is here? If you want to check this out, you can do that. I'm not gonna tell you the answer. I won't. You can look it up. I'm not going to take up the good part about it. Now, from the triangle to polygon stuff, looking at a triangle, the area is half the side times height. And now this S represents the side right here. H represents the height. Look at this rectangle. It has 2 triangles by cutting in here. Look at this pentagon. It has 3 triangles. Hexagon, it'll have 4 triangles. Septagon have 5, and all the way. So whatever sided polygon, there are n number of triangles, and that's the area. So it's like this part is the one triangular sector kind of looking triangle, and you have n number of those. To find out more, please look at the online resources. You can look those up and see how each of those are explaining the area of a circle. Now, one thing also I want to introduce is the NCTM website. Yes, I use this website often to, yes. Anyway, this circle tool in here is, you can do investigation, and there's an intro of it, and you can do problem solving. I will put the link to this website on the description. Now, on this investigation, you can look at the ratio of a circumference and radius, circumference and diameter, or anything of those combinations. And you can investigate how each of the values are related to each other. After you put some of the values on a table, you can create a graph and show how the values are related. This will change the number over here. And problems. It's going to give you a problem. There are different problems you can look for. Right, so that's the NCTM website that I just showed. And that's the end of the video today. So please check out the other videos about geometry stuff that I've done recently. If this video was helpful, please like, leave a comment, and subscribe my channel, and I'll see you in the next video. Bye bye.